We'll now continue our discussion of section 8.3, where we will discuss eliminating the parameter in a parametric equation. Remember that a parametric equation is an equation that has an x and a y and also an additional variable. We have seen a t used in previous examples for time. While a parametric equation is an acceptable way to model a situation, it is often easier to have in our equations only x's and y's. In that case, we need to have a technique to eliminate the parameter t, and that's what we're going to look at in this section. So we'll begin with an example. Our example asks us to sketch the graph described by the parametric equations x is equal to 1 divided by the square root of t minus 1 plus 1, and y is equal to 1 over t minus 1 by eliminating the parameter. The most common method is to solve one of the equations for the parameter and to substitute that result for the parameter in the other equation. So we're going to begin with that method. So again, the first thing that we want to do is we want to solve one of the equations for the parameter t. Because our x equation involves a square root with the t, it is definitely the more complicated one. So I'm going to use my y equation and my goal is to solve it for t. So I'm going to begin by multiplying both sides of the equation by t minus 1. That will cause it to cancel on the right, leaving me just 1. And I'm going to have t minus 1 times y on the left. Remember that our goal is to solve for t. So I'm going to go ahead and distribute the y through that parenthesis. So I have t times y, and then I have y times negative 1. I'm going to add y to both sides. So I have ty is equal to 1 plus y. And then I'm going to divide both sides by y. So t is equal to 1 plus y over y, or you could write this as t is equal to 1 over y plus y over y, and realize that y over y is going to be the same thing as 1. Okay, so that takes care of the first step. I've taken an equation and I have solved the equation for t. Now the next step is to substitute that into the other equation and then simplify. So I'm going to substitute t is equal to 1 over y plus 1 into my second equation. So recall that your second equation was x is equal to 1 divided by the square root of t minus 1 plus 1. And so in place of the t, I'm going to substitute in the 1 over y plus 1. And then we're going to have minus 1 and plus 1. And so this gives us, as we start to simplify, x is equal to 1 over, and we have the square root of 1 over y. The 1 and the negative 1 cancel out. We're now going to simplify this radical in the denominator, so I can take the square root of the 1, which is just going to be 1. I cannot, however, take the square root of the y, and so I'm basically going to break that square root up and simplify the top and leave the bottom. When we do 1 divided by that fraction, remember that we really don't have a way to divide fractions, that instead we have to multiply by the reciprocal. So we're going to see this becoming this 1 times the reciprocal of the denominator. And so basically we have x is equal to the square root of y plus 1. And so this is our equation in rectangular form where we have just the x's and the y's. And so this, we could come in and look at graphing that. However, we are a little more familiar with it in another form. So even though technically I am done right here in terms of what it asks me to do, I'm going to do a little rearranging so that it looks a little bit more like what we're used to. I know that if I'm going to think about putting it in my calculator or even doing a table of values, I would need to solve that equation for y. So I am going to subtract the 1 from both sides of the equation. So that's going to give me x minus 1 is equal to the square root. And again, solving for y, I'm going to square both sides. All right, so our equation looks like x minus 1 squared is equal to y. And again, this is a little bit easier to work with if you were going to type it in your calculator to graph, or if you were to do a table of values. And so if we do graph that on the calculator, we will see that the graph is defined as a parabola. It's only half of the parabola because it's the positive part of that graph. Okay, and that graph is shown on the screen, and you can match that up with what you see on your calculator if you graph y is equal to the quantity x minus 1 squared. And it's worth noting here that the reason that we only see half of the parabola graph is because of the original equations. For example, if you look at your original equation for x, and you note what t values are going to be appropriate, we know that we cannot take the square root of something that's negative. And so this t minus 1 that's underneath this square root has got to stay positive. It has got to be greater than 0. And so if I solve this little inequality, adding 1 to both sides, I see that my t has to be greater than 1. All right, and so that's what we're seeing here, is that that same restriction holds for the x and the y that holds for the t, that we can only use values that are greater than 1. So here's the 1. And we can only use the positive values, the values that are bigger than that 1 for our graph. Okay, so let's move on to another example. Our next example asks us to sketch the graph described by the parametric equations x is equal to 5 cosine theta and y is equal to 5 sine theta for theta values between 0 and 2 pi. Now, there are several different ways to approach this, and we're going to talk through each method. The first method is to recognize that these two formulas are very similar to the formulas x is equal to r cosine theta and y is equal to r sine theta. And so if we recognize that these are very similar to those formulas, then when we compare them, we can see that the r value is going to equal 5. And so remember that from our discussion of polar equations, we know that a graph that has an equation r is equal to 5 graphs a circle of radius 5. And so that is one way to approach this and see that our graph is going to look like this: a circle centered at the origin and with radius 5. Okay, so let's talk about another method, because it's possible that maybe we don't see that. We don't see that these equations that we're given are very similar to those equations that we use to convert between polar and rectangular forms. So if that does not occur to us, we still need another method to work the problem. So let's take our x is equal to 5 cosine theta and our y is equal to 5 sine theta. And let's take one of those two equations. I'm going to use the one with the sine, but you could have done the cosine one as well. And what I'm going to do here is I'm going to solve for the sine. So I'm going to divide both sides by 5. And so we have as our expression y over 5 is equal to sine theta. Now remember that sine, by definition, is the opposite side and the hypotenuse. And so what we have now are two sides of a right triangle. And so let's sketch out that right triangle. Just going to sketch a quick right triangle here. I'm going to put my angle that we're looking at down here in the bottom right. And so I know that the opposite side is y and the hypotenuse is 5. Okay, now what I want to do next is I want to come up with an expression for that missing side. So we know that we can use Pythagorean theorem to find that missing side. So I am going to say, if we let this be a, for example, then I would say a squared plus y squared is equal to 5 squared using Pythagorean theorem. So a squared plus y squared is equal to 25. Remember, we're solving for a here. So I'm now going to move the y squared to the other side, subtracting it off, and then take the square root of both sides. So a is equal to the square root of 25 minus y squared. Okay, so let's put that in right here, and that gives us that other side for our equation. Now that we have a triangle, let's look. We've already used the y equation, so let's go and let's look at the x equation. So we know that our x is going to be this distance on our triangle. Okay, this is our horizontal distance, so that's going to be a measure of x. So what I'm going to do is I'm going to say that x is going to equal this square root of 25 minus y squared. And let's go ahead and square both sides so that we don't have that square root. So I have x squared is equal to 25 minus y squared. And if I move the y squared back to the left, I have x squared plus y squared is equal to 25. And so this equation you should recognize maybe from an algebra class as that of a circle centered at 0, 0 with radius equal to 5. So again, if you were to go that method, you would still conclude that the graph would look like that. Okay, so let me show you one other approach that we could use on this problem. We could take our two formulas as given and we could square both sides of both equations. So this gives me x squared is equal to 5 squared is 25, cosine squared theta, and y squared is equal to 5 squared is 25. Sine times sine would be sine squared theta. Now to finish using this method, we apply a form of the Pythagorean theorem. We look at our x side plus our y side. Now we know that x is equal to 25 cosine squared theta, and y is equal to 25 sine squared theta. When I look at what I have on the right, I note that I can pull a 25 to the front as it's common to both terms. And we know that sine squared plus cosine squared is an identity equal to 1. And so 25 times 1 would equal 25. And so again, this gives us that same equation, x squared plus y squared is equal to 25, which hopefully we recognize from algebra as that of a circle centered at the origin with radius 5. So as you can see, there are several different methods that will work for eliminating a parameter. And so you simply want to use what you feel most comfortable with, or use what occurs to you as the easiest approach given the problem. But they all should result in a graph that looks the same.